Okay, today we're going to be doing LeetCode 136, single number. So we're given a non-empty array of integers called nums, and every element appears twice except for one, right? So here you see 2, 2, 1. For 1, 2, 1, 2, so this is the number 1. If it's one number, you return 1 itself. So given a non-empty array of integers called nums, every element appears twice except for one. Find that single one, right? And they said you must implement a solution with linear runtime complexity and using only constant extra space. So let's first do the one where we use constant extra space, because that's the most intuitive, right? So we're simply going to create a hash map, a hash table, and insert into the hash table each value and the number of times it appears. And then we'll iterate through the hash map again and return the value that appears once, right? So let's do this. So store is equal to counter. Remember, counter is a method of collections that helps you create a hash map. Counter nums. Then for I in range, for num in nums, right? We're going through our nums. If store at num is equal to 1, then we simply return num. Right? So this is O of n space, and this is worst case O of n time, right? So let's see. Voila, it works. The other solution is using bit manipulation. And why does bit manipulation work here? Is we need to first rehash some of our Boolean calculus. If I remember correctly, that's what it's called. So we have OR, right? So 4 or 1 returns either or, right? But if we want to eliminate duplicates, is this OR? No, this is AND. 4 OR. But if we want, this means OR, either or. But if we want exclusive OR, right? Exclusive OR means it means that if you're given two duplicates, right? Say, I think this is the sign for exclusive OR. 1 and 1, it returns 0, right? It means either one of them, but not both. Which means that if there's both, then we eliminate them both. Exclusive OR for this just means either one of them, right? It returns the same result. But exclusive OR for duplicates returns result. Exclusive OR for 0 and 0 will return 0. Exclusive OR for 0 and any other number will return that number, right? 0 and any other number will return that number. 4 or 0 will return 4, right? So same thing with 1, exclusive OR 0 will return 0. So that means that what we're going to do is we're going to have, we can do it two ways. The first one is we can just initialize the first number. We can have our result variable initialized to the first number at index 0. And then 4, 1, 2, 1, 2. We just go through, so we've initialized it to 4. We go through doing exclusive OR. So here exclusive OR will be either or, so it will add them. 5. So 5 exclusive OR, it will add them, and then it will become 7. Result, let me write it here. Right, so our result, let me restart it here. Right, we've initialized our result with a first. So then our result will be 4. And then when we do exclusive OR here, we just simply add it. 5, right, so now it's 5. We do exclusive OR here. we get 7, right? We add it, when we do exclusive OR here with this one, 7 and 1, right? What happens is it eliminates, because it's either or but not both. It eliminates the one that we had previously added, right? So this becomes 6. Exclusive OR 6 and 2. It eliminates the 2 that we had added, and it becomes 4, right? So that's how the exclusive OR works. Let's do it with a different example, right? Okay, let me eliminate this. So this here, you need to remember you need to understand this in order to do bit manipulation. So let's look at how it would work with 2, 2, and 1, right? So for 2, 2, and 1, we initialize our starting point with 2, we get 2. And then we do our exclusive OR between 2 and 2. It returns 0 into our result, right? And then since we have 0 here, 0 and 1, exclusive OR 0 and 1, what does it give us? It gives us 1, right? Because OR and exclusive OR between 0 and any number gives us that number. So as you can see, the number is 1, which is the only repeating. The other thing that we could have done is we initialize result to 0, right? And then we simply go through all of them. But this is an unnecessary step. I think the best thing is to simply exclusive OR from the start, right? So let's do the code for the bit manipulation. And this is the only way to do it in constant time, if I'm not mistaken. So with constant space. So in constant space, the way we do it, constant space, using bit manipulation, right? So what we do is we initialize result variable with first variable in the array. So result at index 0 is equal to result is equal to nums at index 0. Then we iterate from index 1 till the end, right? So for I in range, you can say either for I in range 1 till length of nums, or an alternative would be for num in nums 1 till. I think these two do the same, right? So we're gonna test it out anyways. So you simply get your result, and this is how you do exclusive OR, right? Result is equal to result exclusive OR nums at I, right? And the reason we're starting from here is because, we already initialized the first one, so we're just going to go with that. So by the time it's done, you simply return res, right? Voila. And that works. It takes constant time. Yeah. So let's try this. I'm gonna do that, and I'm gonna do that, because this should also work. So for res num, oh, I forgot to add so this should also work because it's starting from 0 till, yep, and it works. Yeah, so perfect. Another way of doing it is, instead of doing that, you could simply do that equals num. All right. So there's so many ways of doing this. So yeah, so that is the solution, and this takes constant space, but then time. So yeah, that's it, and that's the solution, and bye.